Hello everyone. Today we are going to see the topic construction of DC generator. So, what is a DC generator? Can you guess this device? What is this? Where we are using? For what we have to use? And when we have to use? Yes, this is the generator which converts mechanical energy into electrical energy. We will be using this when the uh, power supply from the TNEB is failure or off. For what we have to use for supplying the loads, we power supply, we will be using the generators. So, rotating electrical machines can be divided into two types. One is generator, another one is motor. A generator is one which converts mechanical energy into electrical energy, whereas motor which converts electrical energy into mechanical energy. Both have uh, rotor as well as stators. So this is the when we give electrical input, the motor will convert this electrical input into a mechanical output. In the vice versa, a generator will convert the mechanical input and produces the electrical output. The best example for mechanical energy to electrical energy is dynamo. So based on the Faraday's law of electromagnetic induction, and the DC generator operates. What is Faraday's law of electromagnetic induction? Whenever a current carrying conductor is placed in a magnetic field, it experiences a force. That force is known as electromotive force. Okay. Uh, what are the equipment basic requirements? We need a magnetic field, a conductor or coil, and relative motion between the magnetic field and conductor. These are the basic components which we use in the DC machine. One is stator, another one is rotor, and fan for cooling purpose, and starter for starting purpose. This is the sectional view, uh, front view of motor, where we have field winding, pole shoe, interpoles, commutator, frame, armature conductor, shunt pole, load terminal, and field rheostat. What is the purpose of yoke? Yoke provides the mechanical support and carries the magnetic flux. It can be made of either uh, cast steel or cast iron. What is the purpose of a field system? Field has poles and field winding, which is made up of electromagnets. In the field system, we have pole shoe, pole core, and field winding. This is the uh, field winding, and the outer part is called as the yoke. These are the different poles, different components which you need in DC generator: interpoles, field winding, armature. In the armature only, we have windings which is placed in. So this part is called as armature. This is called a shaft, and this is called armature winding, which is placed in the slot. And this part is called as commutator, uh, which requires in the DC generator, where uh, it produces alternating flux in the inside the between the magnet and the field. To to get the output as a DC, we will be using commutators. Brushes are used to collect the current from the commutator. It is made up of carbon or graphite, and it is connected with the external circuit. In case of motor, it is used to supply the power to the armature. In case of generator, it is used to get the supply from the armature. This is the brush rock and holders. Can you find the 10 differences in this? This is the simple loop generator, where a magnet is kept in the both the sides, north pole and south pole, and a single conductor is placed with the help of slip rings and brushes, and we are giving an supply. Due to the supply through the carbon brush, the windings will get start rotating, and when the magnet and the electric field is perpendicular, it produces the alternating cycle. Thank you.